First is refraction of light, First is refraction, right? This thing is not working. Not working. So we have discussing today refraction, right? Refraction. What is it? Say this is a refracting surface, right? This is a refracting surface. Refracting surface, and normal to refracting surface is normal to refracting surface. The line perpendicular to refracting surface is known as normal. This is normal. नॉर्मल क्या होता है? लाइन नॉर्मल मीन्स लाइन परपेंडिकुलर perpendicular to refracting surface. Refracting surface, right? Normal is line perpendicular to the refracting surface, right? And there is a incident ray. This is incident ray. This is incident ray. Where it touches, this is known as point of incidence. This is point of incidence. Incidence, right? So there, this is incident ray. Incident ray, right? And this is angle between incident ray and normal is known as angle of incidence, right? This is angle of incidence we have, and after that, when this line is falling, when this incident ray falls on falls on this point of incidence, then two phenomena occurs. One is reflect back in the same medium. This is known as angle of reflection, right? It is called reflected ray. Reflected ray, right? Light ray, light ray, light ray, reflect back, reflect back in same medium, right? And phenomena known as refraction. Oh, reflection, right? Which we are not going to discuss, right? Reflected ray, matlab light ray reflect back in the same medium, phenomena known as reflection, which we are not going to discuss, right? Here today we are going to discuss when it goes in another medium, you know, it This is one medium and it goes in another medium, then it gets deviated from its path. This is known as refracted ray. Refracted ray, refracted ray, right? And this is angle of refraction. This is angle of refraction, right? Suppose this is air. This is air and this is water. This is water, right? So air is rarer medium. It is a rarer medium and it is denser medium in comparison to air, right? It is denser medium. So when light ray goes from one medium to another medium, when light ray light ray goes from one medium to another medium get deviated, get it is get deviated, deviated, right? Deviated. Phenomena, phenomena phenomena known as refraction. Refraction. Getting written? Do it, do it. Get deviated. One medium to another medium get deviated. Deviated. Deviated means change in path, right? Okay. So फिर क्या इसमें क्या है कि when when goes from when when goes from goes from denser rarer to rarer to denser then towards the normal, then towards the normal, towards the normal, right? Towards the normal. And and when when goes from den, denser to rarer medium away from normal, away from normal. Get it? I hope you get this. When goes from denser to rarer medium away from normal, right? towards the normal, towards the normal. This ray is coming from rarer to denser, so it is coming towards the normal, right? See the distance here, see the distance here. This is x and this is y, right? So y is greater than x. So distance is less here with the normal, right? All the measures we are doing with normal, right? So this is the distance. I hope you understand. Okay. Should I rub this? I should. Definitely. Eh? Right. Oh, yeah. Now, another thing is, uh, what is that? Condition for refraction. Conditions for conditions for refraction, right? First, what is first? Angle of incidence. I Angle of incidence should not be equal to zero, right? Angle of incidence should not be should not be zero, right? And the second is both medium both medium both medium should not have should not have same refractive index, same refractive refractive index, right? Get it? Hello. So angle of incidence should not be zero and both medium should not have same refractive index, right? So this is the condition for refraction. And what is law of refraction? Do you know? Should I rub this? So what is law of refraction? Law of refraction. Refraction, right? You are answering like that. If your teacher is asking question to you, so you should tell him that when you have done MSc and PhD, so you are coming to teach us. So why asking for from us? You do not know what is it. So similarly, you are giving me answer. I am asking laws of refraction. You are saying similar to reflection. What is that? Laws of refraction is something like that. You know, I hope you know that this is the x-axis, right? Cartesian plane, this is x plus, x minus, right? Right. And there is y-axis. This is, y-axis, y plus, y minus, right? And we have another axis that is called z-axis. Three-dimensional structure, we have z-axis, right? This is z plus, this is z minus, right? So condition is that, you know, like if we talk about xy, so this is the xy plane. This is xy plane, right? This is xy plane. If I talk about now, we you have, you can have, this is yz plane. This is yz plane, right? This is, yz plane. This is yz plane. This is, xz plane, x xy plane, sorry, xy plane, that is xy plane. And after that, you have that we call, that we call you know that is xz plane, right? This is we call xz plane, right? They all are perpendicular to each other, so this is called xz plane, right? So condition is that first law is saying that first law, incident ray incident ray reflected ray reflected ray reflected ray and normal lies in same plane. Did you understand the meaning of this now, this sentence? Many of us not able to understand this. We learn that, and when it is asked, we start vomiting this. But you should understand this. What is the meaning of it? There are three axes, x, y, z. So there will be three planes, x, y, y, z, x, z. These three planes are there. They all are perpendicular to each other. They all are perpendicular to each other, right? If if we can have better understanding like this, three-dimensional, it is like this. Then we have like this, we have, oh sorry, this is like this, right? This is we have, and another one is, oh my god, how to do that? Okay, so another one is, coming like that, like that, right? So this is the three-dimensional structure we have, right? This three dimensions, so each is a plane. We can say that this is xy plane. This is, sorry, this is all sorry, xz. This we call xz, right? This we call this blue one we call xy, and this is xy, and the green is known as yz, yz plane, right? So just to understand this, so plane, this is we have, right? So this is what I said. Incident ray, reflected ray, and normal lies in same plane. So they all will have same plane, right? They all will have same plane. So this is the first law. It's very simple, but sometimes understanding may be difficult, right? So this is we have, right? Should I rub this side? I hope this side. I made that diagram this side also, so you can be concentrate on that, right? And just wait for a while. This is another one is very important for laws of reflection, right? Refraction, sorry, refraction, refraction. It's very confusing. Refraction, right? Second law is that, right? Ratio of ratio of ratio of sine of incident angle and sine of refracted angle is constant. Did you get this? Ratio of sine of angle of incidence and sine of angle of refraction is constant. It means sine I upon sine r is equal to constant, right? And this constant is known as refractive index. Refractive index. Refractive index. Right? We write it like this. That is called, how to write? It is called mu. Right? This is refractive index. And this is second law. Sine I upon sine r is a constant, that is known as refractive index. You know, in reflection, there is sine I is equal to sine r, right? Angle of incidence is equal to angle of reflection, but sorry, reflection. But here in refraction, sine of incident and sine of refraction is in ratio, and their ratio is constant in a medium. In a medium, right? And more important thing is that this law is also known as Snell's law, right? This is specific. Second law is known as Snell's law. So when your question is, yes, when your question is asking Snell's law, then you have to write this only. When they are asking laws of refraction, then the both you have to write. What is the difference between these two? Laws of refraction and Snell's law. So you must be more conscious about that. Fine. Should I rub this? Okay, I'm going to rub this. Uh, After this, uh, as I told you, sin I upon sin R is equal to constant, which we called mu or refractive index, right? So this is called refractive index. What is this refractive indexes? Refractive index refractive index is ratio of ratio of speed of light speed of light speed of light in vacuum or air, or and speed of light speed of light in medium, right? So refractive index is speed of light in vacuum or air upon speed of light in medium, right? If we say speed of light in vacuum or air is c, that c means speed of 3 into 10 to power 8 meter 10 to power 8 meter per second, right? So and speed of light in medium is v, right? So mu is equal to c upon v, right? Yeah. So again we come, let refractive index of medium 2 is equal to c upon v2, and refractive index of medium 1 is equal to c upon v1, right? What you write? Refractive index of medium 2 is c upon v2, and refractive index of medium 1 is c upon v1. So refractive index of medium 2 with reference to medium 1 is equal to refractive index of medium 2 upon refractive index of medium 1, right? So we can write c upon v2 upon c upon v1, So this C and C is cancelled out and they get reciprocal. So V1 upon V2, right? So refractive index of medium 2 with reference to medium 1 is equal to V1 upon V2, right? This is we have. Should I rub this? This one? Okay. So by law of reversibility, by law of reversibility, by law of reversibility, refractive index of medium 2 with reference to medium 1 into refractive index of medium 1 with reference to medium 2 is equal to 1. Or we can say refractive index of medium 2 with reference to medium 1 is equal to 1 upon refractive index of medium 1 with reference to 2. Right? You won't ask what is the meaning of this. You can write it like this: mu is equal to refractive index of medium 2 with reference to medium 1, or sometimes it is written in your book, or sometimes in exams, mu is equal to 2 1, like this. They both are same. The meaning is that refractive index meaning is that refractive index refractive index refractive index of medium 2 medium 2, right? Refractive index of medium 2. First we have considered this refractive index of medium 2, right? And with reference to with reference to medium 1 medium 1, getting? Then we take second we take this medium 1, right? When positions are changed, then we read in this in same manner: refractive index of medium 1 with reference to medium 2, right? If 1 comes here, 2 goes there, it means refractive index of medium 1 with reference to medium 2. So this is the way how to read this, right? And this is the two way it can be written. Fine. I hope you understand well. Okay. The last topic which I would like to discuss this time, that is there is refracting surface, refracting surface, right? And this is the Normal we have normal. This is medium one. Medium one. We can say it is rarer medium. Rarer, right? And this is medium two, which we call denser medium. Denser medium, right? When incident rays falling from the from medium from when incident ray falling from medium one reaches to point of incidence, it get deviated. It is coming rarer to denser, so it goes towards the normal, right? Like this. This is angle of incidence, and this is angle of refraction. Refraction, right? So what happens? Here its velocity is v1. Here its velocity is v2. In medium one, velocity v1. In medium two, velocity v2. In yeah, and in medium one, wavelength is lambda one, and in medium two, wavelength is lambda two. Right? And I hope you have studied v is equal to v is equal to nu lambda, like this. V is equal to nu lambda. You have studied this, right? So, what happens about frequency? Since since rays are since rays are moving from one medium to another medium, right? Since as rays are moving from one medium to another medium, but source of light source of light is remains same remains same, right? As frequency frequency nu depends on source of light source of light, right? So nu is constant, means hello frequency is constant. Got it? Why it happens? I hope you understand. Rays are moving from one medium to another medium, but source of light is remains same. Remains. Oh, sorry. Remains. We should write here. Remains in uh, remains in same medium. Remains in same medium. right? As frequency depends upon source of light, so frequency is constant because source of light is so source of light is not moving, right? So so frequency is and frequency depends upon source of light, so frequency is constant, right? Source of light is remains in same medium. This is same medium. As frequency depends upon source of light, so frequency is constant, right? Okay. If I say this is here is mu one, here is mu two. So what will be? Mu one is equal to mu two, right? But you can write uh, lambda mu. It means v1 v1 upon v2 v1 upon v1 upon lambda 1 v1 upon lambda 1 is equal to v2 upon lambda 2. Getting? If you have to find lambda 2, then you can write lambda 1 into v2 upon v1 v1, right? So lambda 2 is like this. This is and suppose we divide these two by v2. We suppose we divide both by v2. So this v2 and this v2 is cancelled out, right? And you get lambda 2 is equal to lambda 1 upon v1 upon v2. And what is v1 upon v2? Lambda 2 is equal to lambda 1 upon refractive index of medium 2 with reference to medium 1. Right? I hope you understand this. So this is what we have. What happens when light goes from one medium to another medium? Then velocity is changing, speed is changing. Sorry, speed is changing, the wavelength is changing, but frequency does not change. Frequency does not change because it depends upon source of light, and source of light remains in the same medium. I hope you understand. Okay, so I hope this much is sufficient for today.